Good morning, friends. Today we will study number system. Now, a number can be represented by many ways, and depending on the language, it may vary from one language to the other language. However, in digital electronics, you have to study four basic number systems. First one is that is decimal number system, in which 0 to 9 digits are used to form any number. Okay, whereas in case of binary number system, we can use only 0 and 1 to form any number, to represent any number. For example, in case of decimal number, we represent 12 as this one, whereas in case of binary number, this 12 is represented as this 11002, where this 10 and this 2 represents the base in which this number is represented. Similarly, the third number system is octal number system. In case of octal number system, we can use 0 to 7 digits, means we can use any digit between 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, okay, to represent this number. Suppose we are representing a number that is 34 and this is in 8 with base number is 8. Similarly, the fourth one is hexadecimal number. Here we can use 0 to 9 and then A, B, C, D, E and F to represent a number in hexadecimal form. Okay, where hexadecimal represents a number with base 16, that is, let us suppose 1A2 represented in 16. Here this is the base. Okay, so in case of decimal number system, the base is 10, whereas in case of binary number system, the base will be 2, whereas in case of octal number system, the base will be 8, whereas in case of hexadecimal number system, it will be 16. Okay, now let's start from the first one, that is decimal number system. It's a very, you can say that, frequently used number system in the world. Okay, and you are also aware about it. See here, if a number is represented by decimal number system, then you can write an example like 1, 2, 3, that is 123 written in 10. Here this each digit has some significant value. Okay, each digit has significant value, and in this case, you know it, this position has the least significant value. And this position has the most significant value. Okay, that's why this is known as MSB. You can also write it like this, MSB, and this is known as LSB, least significant value or least significant. Here we have to use this B as digit. So we have to write here, that is MSD, most significant digit, and least significant digit, LSD. Okay, and you know it very well that in this number, that is 123, this position or this significant value represent ones place, this represents tens place, this represents hundreds place, and if we continue towards this side, increasing the value, then it there comes thousand, then 10,000, okay, and so on. So in this particular case, we can write this 1 as 10 raised to power 0. We can write this tens as 10 raised to power 1. We can write this 100 as 10 raised to power 2. It means we can also represent this value like this, starting from the right hand side, that is from LSD, least significant digit, that is 3 into 10 raised to power 0 plus 2 multiplied 10 raised to power 1 plus 1 multiply 10 raised to power 2. This will gives you 100 plus 20 plus 3, and that is nothing but 123 written in again back to the decimal representation. Okay, now similarly, if a decimal number system is used with a fraction point like 123.465, okay, and this number is represented in base 10. So you know it, this digit is nothing but 1 by 10 times of 4. This digit is nothing but 1 by 100 times of 6, and this digit is 1 by 1000 times of 5. So we can say that towards right hand side, each position, let us suppose there are 3 positions are here, then this position can be represented as 10 raised to power minus 1. Look at this value, okay, this one, and this position can be represented by 10 raised to power minus 2. This position can be represented by 10 raised to power minus 3. So we can represent this number as 1 into 10 raised to power 2 plus 2 into 10 raised to power 1 plus 3 into 10 raised to power 0 plus 4 into 10 raised to power minus 1 plus 6 into 10 raised to power minus 2 plus 5 into 10 raised to power minus 3. That can be represented like this. This is 100 plus 20 plus 3 plus 0.4 plus 0.06 plus 0.005, and that will give you again the same number, that is 123.465 10. Okay. Now come to the next number system, that is binary number system. Now in case of binary number system, this bin represents 2. Bin matlab 2. Okay. And we can use only 0 and 1 to represent any number. Okay. So take an example. Suppose we want to convert a number 123 with base 10 in its equivalent number with base 2. Okay. So how can we do this? See here that at this position we have to study, that is conversion of a decimal number to binary number. So we have to start it with like this, that you have to continuously divide this 123 by 2. Okay. So in this way, start dividing and writing remainder at this position. You have to write here remainder. Okay. So divide 123 by 2, that is 6, 1, and with remainder 1. Second again 3, 0 with remainder 1. Then again 15 with remainder 0. Then again 7 with remainder 1. Then again 3 with remainder 1. Then again 1 with remainder 1. Then again 0 with remainder 1. Okay. So now how can we write its converted number? We have to move from this side to this side, taking this digit as LSB. Here please be remember that this is bit, least significant bit, and this is MSB and this bit is LSB. So we have to write it like this, starting from this side, that is 1 1 1 1 1 1 1 1 0 1 1 and so on up to this. So this is the equivalent value of 123 represented in decimal form, and this is the value represented in binary form. Okay. So again check it. If we want to check it whether the number is correct or not, just we have to learn that conversion from binary to decimal. Okay. So the number is this one, 1111 011. Let's check it. 1 1 1 1 0 1 1. We have to find out its equivalent value in decimal. So the method will remain again same as the decimal number. In this case, because we want to find out its equivalent value in decimal, so we have to write it like this. For this one, because this is your LSB and this is your MSB, this bit is your MSB. So we have to start it like this: 1 multiply 1 multiply 2 raised to power, because the base is here 2, 2 raised to power 0 plus 1 multiply, because this 1 represents here this one, 2 raised to power 1 plus 0 multiply 2 raised to power 2 plus 1 multiply 2 raised to power 3 for this one plus 1 multiply 2 raised to power 4 plus 1 multiply 2 raised to power 5 for this one plus 1 multiply 2 raised to power 6, and the number is, starting from this side, 2 raised to power 0 means 1, so 1 plus 2 plus 0 plus 8 plus 16 plus 32 plus 64. Okay, so we have to add these numbers: 8 plus 2, 64 plus 32, that will give you, that is 6, and that is 96. 96 plus 16, 112 plus 8, 120, and this is again 123, and it's proved here. Okay, so in this way we can convert a number and decimal to binary and binary to decimal. However, what about the fractional numbers? Take another example. Example 2. If you want to convert a number 45.26, let us suppose this number 25 in decimal, and we want to convert it into its equivalent binary form. So we have to take 2 steps. Step 1. In case of step 1, first we have to convert this value, that is this value. So the method will remain same, again continuous division by 2, writing remainder here. So this is 22 with remainder gives as 1, again divided by 2, this is 1 1, remainder gives 0, this is again 5 with remainder 1, this is, sorry, this should be 2 here, remainder 1, and this 1 with remainder 0, and this 0 with remainder 1. So again writing in this direction, considering this bit as MSB and this is at LSB. So we can write here that this is 45 का जो इक्विवेलेंट वैल्यू आई है वो आई है आपके पास 1011101. Okay, so this is for only 45 and still we have left behind 0.25. Okay, so we have to continue in next step. In next step you can see here, that is step 2. In step 2 we have to convert this value, that is 0.25. So here in this case we have to multiply it with by negative powers of 2, that is we have to convert 0.25. Okay, so in above step we have divided by it to, sorry, it's my mistake, we have to multiply 0.25 with 2. Okay, and in this way that the what value is we received at this position we have to write here in this place 0. Again we have to multiply it by 2, then it is 1.00. Okay, so in this way you can say that that is 45.25 multiply, sorry, with the base 10 can be represented as 101.012. Okay, okay, so again cross check. We received a number that is 1011, that is 101101.01, and we want to convert it in its equivalent decimal value. So how can we convert? Just start writing this number 101101. Leave it. This is that is 1 multiply 2 raised to power 0 plus 0 multiply 2 raised to power 1 for this one, this plus 1 multiply 2 raised to power 2, 1 multiply 2 raised to power 3, 1 multiply 2 raised to power 4, and for this one 1 multiply 2 raised to power 5, and for this side this is 0 multiply 2 raised to power minus 1 plus 1 multiply 2 raised to power minus 2. Okay, so we can write it like this. We can write this number, that is 10101.01 with binary is equals to, see here, that is 1 multiply 2 raised to power 5, that is 32, plus 1 multiply 2 raised to power 4, that is 1 multiply 16, plus sorry, this number should be 0 here. So we have corrected this digit. Actually, we have to correct. This must be 0 here. Okay, so 0 multiply 16 plus 1 multiply 8 plus 1 multiply 4 plus 0 multiply 2 plus 1 multiply 1 plus 1 by 2, that is, this is 0.5, this is 0 multiply 0.5 plus 1 multiply 0.25. Okay, this will gives you 32 plus 8 plus 4 plus 1 plus 0.25, and it will gives you, that is 45.25, and hence proved. Okay, this will be your answer. So friends, in today's lecture we have studied about studies about number system, and take a review here. That is, there are four different types of number systems in this digital electronic subject. That is decimal number system, binary number system, octal number system, hexadecimal number system. Binary number system can use 0 to 9. Sorry, decimal number system can use 0 to 9. Binary number system can use 0 to 1. Octal number system can use 0 to 7, and hexadecimal numbers can use 0 to 9, and A, B, C, D for high, C, D, E, F for upper sequence. That is, this is for 10, this is for 11, 12, 13, 14, and 15. Okay, and decimal has base 10, binary has base 2, octal has base 8, and hexadecimal has base 16. And we have also studied the conversion of binary to decimal and decimal to binary. Here we have studied first decimal to binary number conversion, in which continuous division is required. Continuous division by 2 is required, and we have to write from top to bottom side in this way, so that the number is represented like this. In this way, this is your LSB, this is your LSB, and this is your MSB. And if the number is to be converted from binary to hexadecimal, binary to decimal number, then we have to multiply it by powers of 2. And we have also studied about fractional numbers, in which the method of fractional number is just reverse here. That is, we have to multiply it by 2, not the dividing by 2 like this, in this way, and just considering only these two bits, that is this one and this one. Okay, now in next lecture we will study how can we convert a number from binary decimal to octal, and octal to decimal, and vice versa, and decimal and octal to binary, and binary to octal. Okay, thank you for watching this video.